everyone. Welcome to the online education for the English medium organized by uh, Brihan Mumbai Municipal Corporation Education Department, right? So today we are going into the ninth standard class, subject science, and the new topic today is your current electricity, right? So today we are going to learn about potential difference and electric current. This is the first session. My name is Vishal Sudhir Chaudhary. I am from the Kurar Village MPS English Secondary School, right? So good morning and welcome to all. Now let us start with the chapter that is your current electricity. Now it is a very important topic with respect to general physics, right? And the various topics and content that we are going to go through the chapter and study, we'll just briefly summarize all the points, right? The first point will be potential and potential difference. Here we are going to learn about exactly how is potential difference generated, what is exactly potential difference, right? How it is measured and the unit for measuring potential difference. Here we are going to see with the help of various examples exactly what potential difference is, right? And how does it correlate with electricity. Okay. Then the next concept will be relating to free electrons and the electric current. Here in this concept we will be learning about what are free electrons, where and how they are generated, right? And how they contribute to the generation of electric current. So here we will be studying all about the free electrons, their generation, and also about electric current. In the concept of electric current, we will be also learning about the units for measuring the electric current. After this, we are going to learn more in details about the various aspects of electricity, right? Here we are going to learn the concept of resistance and resistivity, and also the most important law, that is your Ohm's law, right? So within Ohm's law, we are going to learn the relationship between resistance, voltage, and current. Okay. Then further, we are going to learn about electrical circuits. How are electrical circuits represented? What are the ways they are shown on a diagram? And also the various components that are utilized in the electrical circuit. Here we are going to also learn about the various ways in which the electrical components are represented on a circuit diagram. Okay. Then after that, we are going to learn about conductors and insulators. Conductors are the ones which conduct electricity, and insulators are the ones who do not conduct electricity. So there we'll be seeing the various examples and the reason for them to be conductors and insulators, right? Then the end part of the chapter will include the concept of attaching or connecting the resistors in various combinations, right? Here we are going to see the concept of resistors connected in a series combination and also resistors connected in a parallel combination, right? So this is a very important chapter, right? And I want students, all of you, to concentrate properly, right? Now let us move into the chapter, right? So first of all, we'll go into the brief description about how electricity influences our day-to-day life, how it is very important for us in our everyday life, right? So electricity is of utmost importance to us. We depend on it for almost everything in our day-to-day life, right? So if you look around you in our homes or around you in our city or on the roads also, we will be coming to know that we depend heavily on electricity, right? In our homes right now where we are sitting, you must have a fan above your head, you must have a light, a tube light or maybe a light source, right? Also the the way in which we are conducting our class today, we are using our mobile phones, right? Some of you might be using our computers as well. So on that, in that case, we are requiring electricity in each and every mode. We require electricity to charge our phones, right? We need electricity to run our computers. We need electricity to run your fans, tube lights, and various other electrical appliances. Even on the road, you can see that your street lights, right, they work on electricity. The headlights of cars and all of these things, they run on electricity, right? The large network of railways, they need electricity to run, right? So you can see that electricity is a very important for us for our day-to-day life, right? So in order not to disrupt our day-to-day life, which is dependent on electricity, we have made availability of something like a power generators, right? That is we call as a backup generators. Now these backup generators will provide power when we have a power failure or when there is no electricity available, right? So to avoid inconvenience due to power failure, important services like hospitals, banks, and offices, certain hospitals and banks, they need to run 24 hours every day, right? So they need to have an uninterrupted power supply, right? So in that case, they make use of power generators which generally run on diesel or maybe petrol or kerosene for backup power, right? So you can see the example here, right? You can see a generator which is generally fitted in hospitals or in banks or in offices, right? Which provide them with uninterrupted power supply. That means we heavily depend on electricity, and we do need continuous uninterrupted power supply for 24 hours every day, right? So that explains the extreme importance of your electricity. So we can also see with certain examples now. Domestic appliances using electricity. Domestic appliances means the one in our houses, the household appliances that we make use of in our homes, right? So as I've already given an example, just for example, you have fans running on electricity, then you have ovens, microwave ovens, or which are used for cooking and heating food. Then you must have used, or your mother must have used, mixer grinders at home, right, for preparation of food. Then all of us have refrigerators at our homes to store and preserve food, right? Then some of you might have vacuum cleaners for cleaning purposes, right? And washing machines. All of these appliances make use of electricity, right? And that is a very important source of energy in our homes, right? So electricity is one of the most important ways in which energy, or one of the ways in which energy reaches our homes, which we make use of, right? We have already studied about work and energy and the various ways in which energy is supplied, right? Then moving on further, now there are certain cases where animals, wild animals, also make use of electricity, right? Now some animals also use electricity. Now, fishes such as eels use electricity to catch prey and also for their self-defense. Now these fishes, they are called as electric eels, right? Now they have certain glands positioned near their mouth, which generate a very strong electric current. Now that strong electric current or a shock which is generated for a fraction of a second, right, can be used to kill small fishes, right, so that they can have their food. They can kill the prey and have the food. Or else, if these eels are attacked by larger predators, larger animals or larger fishes, then in that case they can use those electrical glands for their self-defense, right? So they can generate a very powerful shock, a very powerful current for a tiny fraction of a second, right? So these eels have those glands which generate that electrical shock, right? So that is an important case where animals make use of this electricity from their glands, right, for either obtaining food or for defending themselves from larger predators, right? Another example of electricity in nature, right, we do come across lightning strikes during thunderstorms, right? So the lightning that strikes the earth during thunderstorms is an excellent example of natural flow of electricity, right? So when thunderstorms occur, you have those large clouds collecting around us or above us, right? So whenever large clouds are created, you have those tiny water droplets in the form of water vapor and a lot of dust particles present in the air. When those tiny water particles go against each other, right, there is a static electricity being generated within them, right? So in that case, a very large potential difference, or a difference in potentially set up the earth and that of the clouds, right? So at a certain point in time, what happens is suddenly all of that charge, all of that potential gets discharged, right? And what you see is a lightning strike, right? The lightning strike happens to generate about 2 million volts in a very fraction of a second, right? So you can imagine, what if we can collect and store this electricity, right? It is a very large source of electricity, but as of now, we do not have such technology to harvest that energy, right? But you do come across this every monsoon, or whenever we have those thunderstorms, right? It is a very large source of energy. Then moving on, now next is a very important concept of potential and potential difference. For us to understand electricity, the concept of potential difference is extremely important, right? So we will take an example to understand the concept of potential difference. Now, you must have seen a waterfall. Which way does the water flow? As we have seen in the previous chapter, water will always flow from a point of higher potential energy to a point of lower potential energy. So the higher potential energy is at a point where water is at a highest level, right? So as water goes down, it will fall downwards, converting the potential energy to kinetic energy, right? So water will always flow from a point of higher level to a point of lower level, right? So we are going to relate electricity to such an example, right? So electricity also will flow from a point of higher energy to a point of lower energy. Okay, so this is important, right? You need to keep this in mind. So water always flows from higher energy to a point of lower energy, and electricity is also one kind of flow. Okay, Let us go on further. So to understand this, let us take an example of a hydroelectric power station, right? Now in a hydroelectric power station, electricity is generated by making use of the flow of water from a higher level to a lower level, right? So for the generation of electricity, water is released from a dam at a higher level, and due to gravity it flows to the lower level, right? So we make use of the concept of difference in their levels, as in the water stored behind the wall of the dam, it is at a higher level, right? So when the water is released through certain pipes within the dams, it flows at a very high velocity due to the pressure generated, right? So as it flows to the pipe, it moves a turbine and rotates it. So the turbine generates rotational energy, which is made use of in a generator, right? And it generates the electricity. So as the water flows from a higher level to a lower level, right, we convert that energy into electrical energy. Here you need to understand the fact that water will from a higher level to a lower level, right? So we are taking those examples, right, to try and understand the concept of electricity, right? So how it relates here, we have to relate the concept that as water flows from a point of higher level, that is a higher energy, to a lower energy, same way electrical flow or electricity will always flow from a higher level to a lower level, right? What are those levels? We are going to try to understand those further. Okay, so now, just like water, the flow of electric charge between 2 points depends on the kind of electric level at those points. And this is called as your electrical potential or electric potential. Now, let us look at the diagram here. You have two electrodes, two plates, which acts as electrodes, right? The yellow plate at the top is having a positive charge, right? And the red plate below is at a negative charge, right? So, the yellow plate is a positively charged object which is at a higher electrical level, right? And the red plate, it is at a negative electrical or a negatively charged object which is at a lower electrical level, right? So for electricity to flow between these 2 points, they have to be at two different levels. Now, by convention and by rule, the positively charged object is always considered to be at a higher electrical level, and the negatively charged object is always considered at a lower electrical level. So as we have taken the example, as in the case of water, as water flows from higher level to a lower level, same way electricity will also flow from a point of higher electrical level to a point of lower electrical level, as shown by the red arrow. So in this case, the electrical flow or the electricity will flow from the yellow colored positively charged object to the red colored negatively charged object. Okay, now let us take this point further, right, and try to understand. So electricity flows due to the conduction of negatively charged electrons. Now, electricity is a flow of something. Now what is that something? It is electrons. Now as we have, again we will come to the example as in flow of water. Now in water, exactly what are flowing? The water molecules, the H2O molecules are flowing from higher level to a lower level. So in the same way, in electricity also there must be something which is moving, right? That something are those subatomic particles, which are those very tiny particles called electrons. Okay, electrons are having a negative charge. Okay, so if electrons are negatively charged, and you know already that charged particles, right, either attract or repel each other, right? So two positive charges will repel each other and two negative charges will also repel each other. But if you have a positive charge and a negative charge, they will attract each other, right? So as we have discussed, electrons are negatively charged, right? So a negative charge will always flow from a point of negative charge to that of a positive charge, because negative and positive, they attract each other, right? So electrons flow from a point of lower potential, that is negative terminal, to a point of higher potential, that is a positive terminal, right? But conventionally the electrical flow takes place from a positive terminal to the negative terminal, right? So when electricity flows, there are two type of flows. One is a conventional current, as in shown here, where the charge flows from positive end to negative end, right? And the other is your electronic current, where the flow of electrons takes place, which is in the opposite direction, right? So we will be doing that further in detail. So if you look at this diagram here, right, we have two conductors here, right? A positively charged conductor A and a negatively charged conductor B. As we have already discussed, the positive terminal is always at a higher potential, right? And the negatively charged conductor will be at a lower potential, right? And they are connected with a on a stand with insulating cover, right? Okay, so if you connect those 2 points, that is point A and B, means those two conductors, the positive and negative terminal, if they are connected by a conducting wire, the electricity will flow from a positive terminal to the negative terminal. That means from a higher potential to a lower potential, right? So let us move on further. Okay, so potential difference of a cell. Now you must have seen those small cells, the cells which convert a chemical energy into electrical energy, the batteries, right? These are generally put inside watches or wall clocks, or say remote controllers of your televisions and music systems, right? So we are going to discuss with respect to those batteries. Okay, now the difference in potential between the positive and negative terminals of a cell is a potential difference of that cell. You must have seen the cell has two terminals on the opposite ends, right? One of them is a positive terminal, right? And the other one is a negative terminal, right? The positive terminal has a small cap at the top, and the negative terminal is flat from the bottom, right? So if you connect a two wires, or if you connect a wire across these 2 points, electricity will flow through the wire. Okay, so the potential difference is caused by the chemical reactions that are occurring inside the cell, right? So as we have seen in the previous chapter, in this case, the chemical energy that is stored inside the cell is converted into electrical energy, right? So the potential difference that is generated between these 2 points of the cell is made use of, right? So the potential difference sets the electrons in motion and results in the flow of electricity through the conducting wire connecting the two terminals of the cell. So whenever these two terminals are connected by a wire, the electricity will flow, right? And whatever device in which the battery is connected into will be working. Okay, further, so units of potential difference, right? So the amount of work, first of all, we'll have to define exactly how is potential, exactly how it is expressed. So potential difference between 2 points is equal to the work done divided by the total charge transferred. Okay, so the amount of work done to carry a unit positive charge from point A to point B is called the potential difference between these 2 points. Okay, so if you say that we have to carry a charge, means if you have to transfer or move a charge from one point to another point, that means what? There has to be a certain displacement. That means the charge needs to be displaced, right? And if something has to be displaced, there has to be a force applied, right? And we have already studied something, if it is displaced and if there is a force applied, you say that work is said to be done. So work is a product of force and displacement, right? So potential difference, right, is the ratio of the work done to the total charge transferred, right? So potential difference is expressed by the term V, that is voltage, right? And potential difference is
Hey,
expressed
Roti.
by the
Hey,
symbol V,
yaar,
that
mummy
equals to W upon Q. Okay, so V, the formula for volts or voltage potential difference, is equal to W upon Q, and the SI unit for potential difference is volts, right? And that for work, as we have already studied, is joules, and the unit for Q, that is charge, is coulombs, right? So here the terms are: V stands for potential difference, W stands for the work done, and Q stands for charge. Okay, and the units are mentioned there. So the unit for voltage is a volt, a unit for work is a joule, and that for Q, that is charge, is a coulomb. Okay, and the SI unit of potential difference, as you can see, is called as a volt. Okay, further, so now we are going to see the root cause for electricity. Exactly how does electricity flow, and what are the reasons for the flow of electricity through a circuit? Okay, so every atom of a metallic conductor has one or more outermost electrons. Now if you look at the structure of an atom, right, atom in the center, if you look at the structure of the atom here, right, in the center the atom has a positively charged nucleus, right? So you will be studying the structure of an atom in detail, definitely, but as of now let us try to understand this. So in the center the atom has a positively charged nucleus, right? And electrons are going around the nucleus in orbits, right? And the electrons are negatively charged, right? Now in a metallic substance, something like aluminum or iron or copper, the outermost electrons. Now there are many shells or many circular orbits, right? The electrons that are present in the most outer shell or the outermost orbit, right, are very weakly attracted by the nucleus, and they can be transferred, right? So every atom of a metallic conductor has one or more outermost electrons which are very weakly bound to the nucleus. That means these electrons can be removed from those atoms, and these atoms which can be very easily removed because they have very less force of attraction between the nucleus and themselves, these electrons are called as free electrons. And these are the electrons which are responsible for the flow of electricity in various substances like your metallic conductors. Okay, now these electrons can freely move from one part of the conductor to the other parts. So if you can see these electrons, if you can see there are neighboring atoms here, so these neighboring atoms can transfer those weakly held electrons which are the outermost electrons, right? And these electrons can move around, right? So if you have many of the millions of these atoms, right, these free electrons can move freely from one atom to another atom, right? And that is how the electricity is conducted. So if you apply a potential difference across these set of atoms, what will happen? The electrons will flow in a given direction, and hence the electricity will be conducted. Okay, so the free electrons can move freely from one part of the conductor to other parts, and the negative charge of the electrons gets transferred as a result of this motion. So as we have seen previously, in an electric current, the charge carriers are who? The electrons, and the electrons will flow from the negative terminal to the positive terminal, right? So the negative charge of the electron get transferred, and this is the cause of current. Okay, and these, the charge carriers are these negatively charged electrons, right? Further, so let us try to understand how exactly current flows through a wire. Okay, now when a current or when a conducting substance like a wire is not connected to a cell, or when it is not connected to an electrical source, its free electrons move randomly in all directions in the space between the atoms, right? So if you can see the diagram below, the red particles represent the electrons, right? So when the conductor or when the substance is not connected to a current source or like a cell, the electrons are freely moving randomly in all possible directions, right? So there is no net flow of electricity, right? But when we connect the two ends of the wire to two terminals of a cell, an electric force acts on them. So when you attach a electrical source or attach a battery or a cell, the electrons start moving in a given direction, right? So electrons being negatively charged, they will start moving from the negative to the positive terminal. Let us look at that example. Okay, now let us look at this diagram below. Okay, so you had that same conductor which had those electrons, right? Now when you apply or when you attach a cell, right, now you can see here the cell has two terminals, positive and a negative. Now there are various ways of expressing the cell. So this is cell which is expressed, right? A positive terminal is shown by a larger line, and the negative terminal is shown by a smaller line, right? There has to be a gap in between. Okay, so the way in which those electrical components will be expressed, we are going to see it in further classes, right? As of now, try to understand this, right? So you can see the electric current will flow from the positive terminal to the negative terminal, right? But the electrons will flow in the opposite direction, that is from the negative end to the positive end, right? So you can see the electrons are flowing from right to the left, whereas the direction of flow of electric current is from the left to the right. Okay, we will see that further also, right? So due to the flow of these electrons, the current starts to flow through the wire, and this motion of electrons is irregular, but there is a definite non-zero value to their average velocity, right? Even though when the electrons are moving, right, there are those atoms which have the nucleus in the center, right? So the electrons, when they are moving, they are constantly being attracted and repelled by various nucleuses and electrons around them. So they are moving randomly, their direction is irregular, but when you add up all the directions, when you look at the overall picture, the electrons seem to be moving in a given direction, and which is the cause of electricity, or which is the cause of the current flow. Okay, Let us try to understand this again in some another example, right? So an electric current is a flow of electrons through a conductor, as we have already discussed. Now, electrons in a conductor move from the negative terminal to the positive terminal. Now, if you look at this figure again, right? Now, the substance, the conductor is a cylindrical substance which has those two ends A and B, right? Now, within those two ends A and B, inside the substance, inside the conductor, the electrons seem to be moving from point B to point A. That is from the negative terminal. You can see the point B is connected to the negative terminal of the cell and point A is connected to the positive terminal of the cell, right? So the electrons are moving within the substance from point B to point A, whereas the flow of conventional current, which is shown by those block arrows on the black conductor, right? You can see the conducting wire is black in color, right? On that black conductor, the conventional current is shown by that red block arrow on the wire, whereas the electron flow is shown by those red arrows outside the conductor, right? Okay, which is showing the direction from negative end to the positive end, right? So the conventional flow is in the opposite direction, that is from positive end to the negative end, and the electron flow is from the negative end to the positive end, right? So you can see electrons in the conductor move from the negative terminal to the positive terminal, and conventional current is taken to flow in the opposite direction, that is from the positive terminal to the negative terminal. Now students might ask a question here, why is it so, sir? Why is the direction different? The simple reason for this is when the phenomena of electric current was discovered in the early days, the existence of electrons was not known. Electrons were not discovered by then, right? So initially in the early days, scientists believed that there must be a positively charged particle which is moving. Okay, so a positively charged particle will move from the positive terminal to the negative terminal. But in the early 19th century, when the discovery of electrons was made, later it was recognized that, oh, there are negatively charged particles which are moving. And then the concept of a conventional current and an electronic current came by. Okay, so instead of changing the circuit diagrams all over the world within all the books and textbook and study material that was generated, the scientists made an idea to just add up a new type of current. Okay, that is an electronic current which moves from negative end to the positive end. Okay, so let us move on further, right? So let us define what is electric current quantitatively, right? So electric current, now the symbol for electric current is I, right? One more symbol we have seen previously, that is for potential difference. It is given by V, okay, voltage. And the symbol for electric current is I. Okay, there are going to be lots of symbols in this chapter, various ones of them, so you need to be understanding those and memorizing those. Okay, so electric current I is defined as a charge passing through a conductor in unit time. Okay, charge. Now you can see, or we have seen that the charge that is flowing is which particle? The electron. So the electron is a cause for that flowing charge. Okay, so if a charge q is flowing through a cross section of a conductor in time t, then current I equals to q upon t. Okay, so here q is a symbol for what? The charge. Okay, so that can be represented by the moving electron. Fine. Okay, and the definition of current or current is defined as charge passing through a conductor per unit time. Okay, and its mathematical expression is I equals to q upon t. Okay, so it is very important. Let us move on further. Okay, so the units of electric current we will see right now. The I, the definition of I, the current is what? Q upon t. The Q is what? The charge. So the SI unit of charge is coulomb, 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 given by capital C. Okay, then the moving charge particles are who? The electrons. So we need to know the exact charge of an electron, right? So the charge of one electron is 1.6 into 10 raised to minus 19 coulombs, right? It is a very tiny charge, right? Each electron, a single electron is a very, very tiny charge. But when you look at a conductor, right, there are millions and millions of electrons which are moving, right? So when you add up those, it gives you a larger charge. Okay, then further, the SI unit of electric current is ampere, that is A. So you can see there are lots of symbols coming across, right? C for coulomb, then A for ampere, I for electric current, V for voltage, right? Q for the charge, and so on. So you need to be, tabulating those various symbols, right? So that you can memorize those. Okay. So let us define 1 ampere. Now, 1 ampere current is said to flow in a conductor if 1 coulomb charge flows through it every second. So if you look at a cross section of a wire, right? If you cut across a wire, right? And if you measure the amount of charges passing through that cross section in 1 second, you can calculate the current in amperes, right? So let us define it again. 1 ampere current is said to flow in a conductor if 1 coulomb charge flows through it every second. So 1 ampere equals to 1 coulomb upon 1 second, or I can alternatively say 1 ampere is 1 coulomb per second. Okay. Further, let us look into the example of electrical current or example of a numerical, right? So a current of 0.4 amperes flows through a conductor for 5 minutes, right? So here they have given the current, the value of current. Now current, the symbol for current is what? I. It is given as what? 0.4 A, where A is a unit, that is ampere. Okay, it is flowing through a conductor for 5 minutes, right? So the time t is given as 5 minutes, right? Because we are always going to solve the numerical, the SI system, you need to convert time into seconds, right? So 5 minutes happens to be 5 into 60. Why? Because each minute happens to have 60 seconds. So 5 into 60 happens to be 300 seconds. Now what have they asked? How much charge would have passed through the conductor? So they have asked the the value for Q. Now the formula that is we have understood or we have learned is I equals to Q upon T, right? So if you rearrange, Q will be equal to I into T, right? So Q equals to I into T, and the value of I, if you substitute, is 0.4 amperes, and the time is 300 seconds. So if you multiply 0.4 into 300, we will get 120. And the unit for Q, the charge, is coulombs, right? So therefore, the charge passing through the conductor is your 120 coulombs, right? So if you just slowly go through or slowly revise the content that we have done today, we will just briefly discuss what we have done today, right? So in the beginning, we have seen the various applications of electricity all around us, the dependence of humans on electricity, right? In our day-to-day life, we make use of electricity everywhere all around us, right? So electricity happens to have a large importance in our day-to-day life, right? So we have made various arrangements so that the uninterrupted power is available to us, right? So we can have generators set up, we can have batteries in the form of inverters at our homes. On computers, we have those UPS devices which are called as uninterrupted power supply, right? So in a case of power cut, right, the computer will still keep on running for 5 to 10 minutes. So we, because of our heavy dependence on electricity in our day-to-day life, right, we have made these alternative arrangements in the form of your backup generators or inverters and various things, right? So that we can have emergency services like in hospitals. In hospitals, we have operation theaters. In banks, you have those ATM machines and all, right, which have to be continuously supplied with electricity, right, for efficient working. Okay. Then the domestic appliances that we use at home, like fans, ovens, tube lights, washing machines, mixer grinders, right, we have seen such examples. You can make a list of many more appliances that we come across in our day-to-day life that run on electricity, right? Then we have also seen certain examples of animals utilizing electricity, right? So some animals also use electricity, such as eels, right? They use their electricity for killing the prey or for protecting themselves from predators, right? One more example I can give is inside our body, right? The signals, the nerves, right, which send signals from the brains to the various organs, they also make use of electrical synapses. They are called as electrical synapses. So within the neurons, right, the signals for working our muscles and for moving our body are also sent through electrical synapses. They are very low potential, very low voltages they are. Okay. Then we have also seen the examples of electricity in nature in the form of your lightning strikes, right? We are very high powered, extreme sources, right? Then next is the example of your potential and potential difference, where we had seen that always water will flow from a point of higher potential to a point of lower potential, right? As in the case in conversion of energy, where at a higher level, water will have a higher potential energy, and as it falls down, it will come down to a lower potential energy, right? Same way in a power converted from Electricity is converted as water flows from a higher level to a lower level, right? Then further, potential and potential difference. Now here we had seen the example of two charged conductors or two charged plates, right? Where the yellow plate was a positive plate and the negative plate was a red plate, right? So the electric potential will always flow, or the electricity will always flow from a point of higher potential to a point of lower potential. Now, by rule, by convention, the positive terminal is always taken to be the terminal at a higher potential by rule, by convention. Okay, so the electricity, the conventional electricity will always flow from positive terminal to the negative terminal. Okay, and the difference in levels between these two terminals is the electrical potential. Okay, then further, this is what we had seen, right? So when you connect those conductors, or when you connect those terminals which are oppositely charged, the positive and the negative terminal, the electricity will flow between these terminals from positive end to the negative end, right? Then further, so we had also discussed about what the potential difference of a cell. A cell always has two terminals, the positive and the negative terminal, right? So when you connect those two terminals by a cell or by a conducting wire, right, and if you connect a light bulb in between, what will happen? The current will flow through the wire, and thereby the current will flow through the bulb as well, and the bulb will glow, right? Okay, so that is how in a battery or in a cell, the chemical energy is converted into your electrical energy, right? Then we have seen the units for potential difference, right? So potential difference between 2 points is the ratio of work and total charge transfer. Means potential difference V is equal to W, that is work, divided by total charge transfer, that is Q. So V equals to W upon Q. And if you substitute all of their SI units, right, the voltage or potential difference is given by the unit of volt, and work is given by the unit of joule, and Q, that is charge, is given by the unit of coulomb. Okay, so 1 volt equals to 1 joule upon 1 coulomb. Okay, then we had seen the concept of free electrons, right, where every atom, every metallic substance happens to have those free electrons around them. Now the free electrons are the electrons which are situated at farthest from the nucleus in the outermost orbit. So they will be very weakly held by the nucleus, and they can be easily removed, right? So metals have very loosely bound electrons, right, which can be removed. So when you have lots and lots and lots of atoms, right, what can happen is those free electrons will be free to move within those atoms. Okay, and thereby, right, having the ability to transfer a charge, and hence they can conduct electricity. Okay, so when you have a wire which is not connected to any external electric source, or when it is not connected to a cell, the electrons, the free electrons within that conductor are free to move in all the possible directions. They are moving randomly. But as soon as a cell or an electrical source or a source of current is connected to that conductor, the electrons will start moving in one direction, right? So as you can see in this case, the electrons are flowing from the negative end of the terminal to the positive end of the terminal, right? Okay, and that is what is your electronic current, which flows from negative end to the positive end. And the conventional current is the current which flows from the positive end to the negative end. Okay, the reason for this is what the electricity, the concept of electric current was invented or was discovered long back, right? So at that time, they were not aware about the presence of a negatively charged particle. Okay, so initially they believed that electric current will flow is flowing from positive end to the negative end. That means there must be a certain positively charged particle, but that is not the case. As in the early 19th century, when the discovery was of electron was made, then they realized that, oh, there is a negatively charged particle exactly which is moving, right? And then thereby came the concept of your electronic current. Okay, that is why these two are in the opposite direction, but you need to remember that. So conventional current always flows from positive terminal to the negative terminal, and the electronic current or the electrons flow from the negative terminal to the positive terminal, right? That is what is the concept that we had discussed in detail, right? Then the definition of electric current we saw. So electric current I is defined as a charge passing through a conductor in unit time, right? So current I is given as what? Q upon T, where Q happens to be the charge flowing through the conductor, and T is a time for which the current is flowing. So if you can see the current flowing is inversely proportional to time. So higher, more the time, Okay, accordingly you will get the current. Further, so units of current we saw. So SI unit of charge is what your coulomb, right? Because the charge carriers are electrons, we need to know their charge. So the charge of one electron is 1.6 into 10 raised to minus 19 coulombs, right? And the SI unit of electric current is ampere A, where 1 ampere current is said to flow in a conductor if 1 coulomb charge flows through it for every second, right? So 1 ampere is given as 1 coulomb per second, right? So that is how we conclude our class. So for students, I will like you people to prepare, or I will like students to prepare the different definitions. I will want the students to prepare the definition for ampere, the definition for electric current I, right? Then the value of charge of the one electron, right? Then the next is what the direction in which the conventional current flows and the direction in which the electronic current flows. Okay, then students should be preparing, next is the definition of free electrons, exactly what are free electrons. Then students should be preparing the definition of potential difference, the mathematical form, and the unit of potential difference. Okay, okay. So that is how we will conclude the class for today, and in the next class, right, we will study Ohm's law, right, and the various other concepts relating to electricity. Okay. Yes, sir. Hello.
Yes, sir. Yes, sir. Thank you.
Yes, sir.
Thank you.
Yes, sir.
Yes,
We will
sir.
like to end the class today. Yes.
Yes. Yes. Thank you so much.
Okay. Thank you so much. Yeah. Okay.
Madhuri madam. Hello. Hello. Hello.
Hello, sir. Are you able to hear me?
Yes, teacher. Good morning, teacher.
Yes, good morning.
टीचर एक छोटा सा यहाँ पे ब्रेक लेते हैं, उसके बाद स्टार्ट करेंगे.
Sure, sir. That will be great. Thank you.
Yes, thank you, टीचर. स्टूडेंट्स, हम यहाँ पे एक छोटा सा ब्रेक ले रहे हैं. लेक्चर शार्प 10:40 को स्टार्ट किया जाएगा. थैंक यू सो मच.